Hello and welcome to the Daily Space for today, October 25th, 2019. I'm your host, Dr. Pamela Gay, and I am here to put science in your brains. Most Mondays through Fridays, either I or my co host, Annie Wilson, will be here, bringing you a quick rundown of all that is new in space and astronomy. And since it is one of those most Mondays through Fridays, I think I'm going to give you a quick rundown of all that is new in space and astronomy. Today we have a variety of stories coming to us from all over the universe, and I'm going to start with a story of galaxies on the go. This is an image, and here I need to look at my notes, of a Bell 1758. This is a system that back in the 1950s was cataloged by George Abell as a single cluster of galaxies. But over the decades, as we've observed it with more and fancier and bigger and more diverse telescopes, we've been able to realize this is not just one cluster of galaxies, but rather this is a set of two pairs of merging galaxies. So that makes it four galaxies, not merging galaxies, merging galaxy clusters. This is not one galaxy cluster, not two galaxy clusters. This is four galaxy clusters. This particular setup includes two different sets of mergers that are in two different sets of merging that are all in the process of merging into a single system. And the way we're able to get at that understanding is actually by looking at this in a variety of different wavelengths. You can only really understand something when you've seen it from all sides and in all colors. And while we can't see this from all sides, we can see it in all colors. And Chandra X-ray observations, which you see here superimposed on optical observations, show that we have two systems with very hot gas in the center. That's the white that you see embedded in the blue. And these systems have that hot gas getting distorted out behind them. One of the cool things that we've been able to learn about this system is that the system you see on the left, where it has that smooth, hard edge of white X-ray emission, that's the shock wave of the system as it moves out. These two systems are actually moving past each other at this point, having already passed near each other, and probably they would have, had we been around a billion or so years ago, we would have seen them superimposed on one another. But right now we're seeing them after they've crossed, and over time these systems are going to spiral together, crossing and shredding themselves, extending out long trails of gas and dust behind. Systems like this allow us to get a snapshot on the evolution of our universe. And these kinds of collisions actually affect all the galaxies inside these clusters. The shock waves that they're going to experience as the systems collide, as the dark matter halos of each of these four different clusters merge and combine, all of these different interactions are going to trigger massive amounts of star formation. And once that star formation is done, it is done for all the galaxies for all time, because these systems will be largely stripped of the needed gas and dust for future generations of stars. And right now, by using a combination of the Chandra X-ray Observatory as well as a ground-based multi-mirror telescope, they are able to piece together where the heavy elements are today and start to get an understanding of how these heavy elements move around and how star formation is triggered in these different systems at this point in time. Now, one of the frustrations of looking at an ongoing event such as this one is this event is going to take billions of years, and over the course of even a human generation, all we can see is essentially this one frame in that multi-step evolution. So the way we understand how these systems collide, how they're affected, and how they move forward isn't just through computer models, although that has a large part of how we do it today. But over the history of astronomy, the way we've come to build our current understanding is by looking at a myriad of different merging systems and seeing what they look like at each of the different steps in, well, galaxy cluster mergers and each frame, even though they come from different clusters, even though they come from different angles, the physics is the same everywhere in the universe. And this allows us, by looking at enough different objects, to get an understanding of how, on average, galaxy cluster mergers take place. This is sort of like imagining you had to try and understand all of the life and death of a human being by looking at humans on the Earth in a single point in time. Well, if you looked out across a crowded enough space, you could see all the ages. You could see all the sides. Well, not the bottoms of feet, probably, but you'd get there eventually. And this is how we understand our universe. There's going to be some gaps, and there are some gaps in our understanding. But it's cool how we are, given how long these processes take, able to understand what has happened and will happen over the course of our universe's history and future. And from here, we move on to a much less grandiose story. There has been the discovery of a world orbiting in a triple star system. In this particular story, we don't normally bring you the discovery of yet another planet, because let's face it, there have been the discoveries of lots and lots of planets. And thank you, Grandolph, for the following. There have been discoveries of lots and lots of different planets. And if we brought you every single planet's discovery, that is all we would ever do forever and all time. But this particular one is interesting because, first of all, finding a triple red dwarf system isn't an everyday occurrence. This is one of those things that we really hadn't quite expected to see. So here we have it. There is a triple system of 3 red dwarf stars that all somehow came together in one gravitational heap. And when watched carefully, a planet has been found transiting the primary star in this system. And this system is given the ever so eloquent name of LTT 1445. This system is 22.5 light years away from Earth. And that planet that was found transiting around the primary star, it has a diameter just 1.38 times the diameter of our own planet Earth. Now, at this point in time, we don't yet know the mass of this planet. Because we don't know the mass, I can't tell you, is this a rocky world? Is this a gassy world? What I can tell you is after the publication of this paper announcing this discovery, the group of scientists led by Christiana Walters, let me make sure I'm getting that right, Christine Winters, I totally did not get that right, led by postdoctoral research scientist Christine Wilters at Harvard Smithsonian Astrophysical Observatory. They have time on Hubble, Spitzer, and the Giant Magellan Telescope to go looking for the atmosphere of this planet and to measure its mass. This means that we're going to be able to figure out, is this a rocky world? And if it is, we're going to be able to measure its atmosphere. Now, it could be, it turns out, this is a giant rock with no atmosphere. It could be this turns out to be a gassy world, which of course has an atmosphere, but who cares? That's the definition. But this could be that first terrestrial world with an atmosphere that we're able to observe. And the reason we're able to do this is it's only 22.5 light years away. And that 22, thank you, Popple Jeppy, for the follow. That 22.5 light years away, that makes it the second closest exoplanet so far discovered. So here is looking forward to finding out what kind of a world this is and what kind of atmosphere it just might be gravitationally holding on to. Now, from here, and I'm going to try and fix, I'm noticing that we're having some alignment issues, and I'm going to fail to fix it and apparently open up my dictionary. Um, Trying to fix this problem that we currently have. Now, the dictionary is determined to open right now. So we're going to deal with just having a little white line there. Okay, so in our final story of the day, this is an artist's rendition of a comet. This is not actually a comet, but this is a potential comet. And I apologize for the dogs in the background. Apparently, we're getting a package or something right now. So this particular illustration is related to a new story that goes through and describes the mechanism by which we may be able to get what are referred to as Jupiter class comets. These objects are able to, and here I'm sorry, I'm looking at my notes again. The correct nomenclature is not Jupiter class comets, but I'm not seeing in my notes real fast. So anyways, we have in our solar system this belt of icy objects that extends from just inside Neptune's orbit, which is at a distance of about 30 AUs, or 30 times Earth's distance from the sun. And this band of icy objects that includes that includes Pluto and Eros and a variety of other icy objects. This band of icy objects extends out to 50 astronomical units away from the sun. And we believe that a number of the comets that we see originate from this Kuiper belt of icy objects. And new computer models have been able to figure out how to get these objects through gravitational perturbations to wend their way from the Kuiper belt through the ice giants Neptune and Uranus, through the gas giants Saturn and Jupiter, and end up in a realm inside Jupiter's orbit. And we name objects in this band centaurs. And right now we know of about 500 objects that we identify as centaurs. These are periodically active objects that look like comets, but are at a distance that you wouldn't expect to see cometary activity. These are objects that are sometimes just passively orbiting. And it turns out that once an object ends up in the centaur region, they're probably only stable there for about 1,000 years before they get sent careening into the inner solar system as these periodic Jupiter-class comets. Now, by figuring out the mechanism by which you get Kuiper belt objects into the Centaur region, by figuring out how long things last in the Centaur region, and by looking and seeing what is the size distribution of things in the Centaur region, they're able to start to figure out, well, just how often is it that we probably end up with massive, huge, glorious, brilliant comets to look at? And the answer is about every 50,000 years, an object that's maybe 40 miles across is going to make its way all the way in to that Centaur region. And then once it's there, it has the potential to get sent all the way in to our inner solar system. And I don't mean 41, I mean 4.1. I'm sorry, decimal points matter. I clearly did not get enough sleep last night or enough caffeine this morning. Thank you all for your patience while I periodically misspeak rather radically. We currently have one large object that we know about that is considered a centaur. This is Comet 29P, Schwarzmann-Wachmann, or Wachmann rather. And this particular object is one of these large multi-mile across comets. And while it's probably stable there for now, this means that sometime in the next 1,000 years or so, our distant relatives may be able to see the most mighty comet seen in human history. So this is where I get it making such a grand statement as seen in human history. If the model is accurate and an object like this only ends up in the Centaur belt every 50,000 years, and human history really only goes back about 50,000 years, Well, we probably haven't had another one of these objects. And so that object we see today, it's going to be the first great big one for the Homo sapien. So that's pretty cool to think about. Anyways, as AstroWise points out, we are currently comet deprived. So here's to hoping that something maybe a bit smaller but still rather grand comes in and gives us a show sometime in the not that distant future. And that really rounds out the show for today. That's all I've got. But this is not all astronomy podcasts have for today. Later on, right here on twitch.tv, we are going to be simulcasting Astronomy Cast. This is the weekly podcast that I do with my co-host Fraser Kane, who's the publisher of Universe Today. And we are going to be talking about astrobiology and about the Viking probes, didn't they, discovery, not discovery of life. So tune in right here on twitch.tv in, I think, an hour and a half, a little more than an hour and a half. And that's what we're going to be bringing you. But before we do that, I am going to be answering your questions. So please go ahead and type them in. And while you're typing them in, use that purple circle with a darker purple star inside of it. And that will help me find your questions. While you type them in, I'm going to remind you that the Daily Space is published by the Planetary Science Institute, a 501c3 nonprofit dedicated to exploring our solar system and beyond. We are produced by Susie Murph, who is currently on vacation. So any of you who have gone looking for YouTube videos this week and are hopefully here now, because otherwise you're not going to hear this, the delay is because Susie is the one who posts things on YouTube, and since she's on vacation and she's paid hourly and I don't want to take her work away from her, we're just waiting for her to get back before things get posted up on YouTube. So while this is mean to you, it is a kindness to her, although she's probably going to have more work than she enjoys next week, but she'll be paid for it. And the reason she'll be paid for it is because of you. Your bits, your donations, your patronage at patreon.com is how we're able to keep this show going. So thank you for all that you do. And the best way that you can support us right now is to become our patron at patreon.com/CosmoQuestX. The reason this is the best way is because it's also a way that we can get you more for your donation. We will be sending you notes for our Daily Space episodes. We'll send you updates on what's going on. It's basically the first group of people that we communicate everything that happens around CosmoQuest to. So please consider joining our family over at Patreon. Okay, now to see what questions we have. Scrolling back up. So the question that came at the beginning of the show, instead of thank you for the bits, thank you. I have no dog down here right now, so thank you from me. So we had a question at the beginning of the show asking why I was showing a fish tank instead of a sleeping dog, as I normally show in the pre-show as everyone wanders in. It's because the dogs were asleep upstairs, and I didn't want to, wake up Eddie to bring him down the stairs. Let sleeping dogs lie. This is what they always taught us. So I figured, you can watch a fish tank instead. Hello, everyone. Looking for questions. Mythtown says moo. I do not know why, but moo. Scrolling. Oh, Broken Symmetry. I'm glad that you enjoyed the live stream from the pub last night. For those of you who didn't catch it, there was a very dark live stream. I gave a talk at a brew pub about half an hour south of here on Bennu, and streamed it out as best I could using the bar's Wi-Fi. So Larry Weird asks, do you know of any other merging galaxy clusters? Let me pull that image back up. Yes. In fact, it's through the mergers of galaxy clusters that we're able to really figure out that dark matter is a stuff and not an error in our understanding of gravity. There is a cluster set called the bullet cluster that is in the process of merging. And by imaging background galaxies and looking at how they've been gravitationally distorted through microlensing events, we are able to figure out, not microlensing events, that is a wrong turn of phrase. Through gravitational lensing, we're able to figure out just where in this field all the dark matter is lurking. And we were able to see that the gas, dust, stars, and dark matter all have their own slightly different orientation in these merging systems. So go ahead, Google the bullet cluster. It's a pretty cool bit of science. So Henny's Warverp is asking, are the dark matter clouds also merging? So in the initial stages of these clusters passing next to each other and sometimes even through each other, the dark matter passes through. It generally doesn't collide. Over the fullness of time, however, you're going to end up with a massive singular dark matter halo as these systems all settle together. We refer to dark matter as a non-collisional particle. So Hanny goes on to also ask, would this be dangerous for any inhabitants? I mean, there's a lot going on. I assume that that question is related to our 3-star system. I haven't looked at the particular models for this solar system, but quite often when you have these triads of stars, you'll have 2 that are in a close binary around one another, and a third that is outside of this going around the inner 2. And depending on how the planets are aligned, it's perfectly safe. Now, you can form a system that is not perfectly safe. And as I said, I haven't gone through and looked at that aspect of this paper, so I don't know what the long-term probability of destruction is for this particular planet. Looking for more questions. I love the question. It doesn't have a star in front of it, but I love the question. Imagine the religions that would arise on a world with that many stars. So Henny goes on to also ask, how will this compare to any comet that we've seen in the last 100 years? Will it be visible during daylight? So whether a comet is visible during the day or not isn't just a function of how big the comet is, but also the geometry of the solar system when it comes through. It could be that that star makes the mistake, from our perspective, of course, of being at its closest approach to the sun when we're on the opposite side of the sun and unable to see it. We do periodically get comets that are bright enough to see during the day. Comet Not a few years ago, if you knew exactly where to look, you could see its nucleus on the sky. But you also can see Venus during the day if you know exactly where to look. So it's always a matter of just what you consider visible during the day. If you mean, will it show up more like the contrails of an airplane? If it happens to be, as has happened before, that it is passing nearest our planet at the same time that it's nearest the sun, yes. And in fact, and this has happened in the past, if the comet tail is pointed straight our way, as the comet is closest to the sun, we will also get a remarkable meteor shower at the same time. There is a jazz standard, stars over about Alabama, or stars falling over Alabama, about a meteor shower. Looking to see. I love the way Henny went, rocket, 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 rover, Pikachu! That pleases me far more than it should. Looking to see if there are other questions. There is a discussion of jelly beans. Hey, Bill Nash, welcome. For those of you who don't know, Bill Nash is another one of the educational streamers right here on Twitch. He's also a fabulous photographer, and it's the how to do photography and process your images that he's often teaching here on Twitch. Go ahead, check his stuff out. He's been working on telescopes periodically, And so he is a place where you can get an added dose of beauty and sometimes astronomy. New moon this weekend, he points out, taking the scopes out to Joshua Tree. That is amazing. We are probably going to be rained on this weekend. Okay, so I seem to have hit the bottom of your questions. I do need to record our podcast before coming back to record Astronomy Cast live right here on twitch.tv as well as over on YouTube where our standard channel is located. So if you want to check it all out, you can. Just come back in about an hour and a half and we will be here talking about astrobiology and the Viking experiments. Okay, so as a reminder, we are a product of the Planetary Science Institute, a 501c3 nonprofit dedicated to exploring our solar system and beyond. We are supported by you, your bits, your donations, your patronage at patreon.com/CosmoQuestX. That's what lets this show happen. We are so grateful to all of you who have already supported us. To those of you who keep showing up day after day, week after week, if you're not supporting us, consider doing so and make it easier for us to not worry about paying Susie. Okay, that's all I've got. Wherever you are in the world, have a fabulous morning, evening, or afternoon. Bye-bye.